Hello everyone, in this video we're going to cover porosity interpretations. Danomics has several options for porosity determination, including porosity from density, sonic, neutron density, Roma-Yuma methods, and the mineral inversion. So let's get started. So where we left off in our last video, we had just finished our mineral inversion. And so now if we go forward to our porosity interpretation, we'll need to select the porosity method that we'd like to use. As I mentioned at the start of this video, Danomics has several options for this. And you can choose which method you'd like to use on a zone-by-zone basis. If you select a method, for example, like the neutron density porosity or density porosity, you'll need to set your matrix density here, and that's this parameter. And you'll see this is already filled in for us from our V-Clay interpretation, as those parameters are linked. If you wish to unlink those parameters, you can click this option here, which will then give you the option for putting in a row B matrix. If you do a sonic porosity, you'll need to put in the specific properties for your sonic porosity. You'll also have to decide if you want to TOC correct your porosity, and that option applies to the neutron density, and sonic methods, as well as the grain density and Roma-Yuma methods. For the mineral solver porosity, the TOC correction is already applied, and so no effect will take place if you use this option. So in general, Danomics strongly recommends that if you have done the mineral inversion, that you use either the mineral solver porosity or the strict version of the mineral solver porosity. The only difference between the two is whether or not it uses the fluid density that comes out of the mineral inversion solution. To do so, we would just select the strict porosity, and now we don't have to enter in a row fluid. So there is one parameter that you would still need to set, and that is the parameter that controls our conversion from a total porosity to an effective porosity. And this means we need to set the clay porosity parameter. And this is a parameter that you can't really measure, and it's very difficult to calibrate. And when you talk to petrophysicists these days, there's really a debate on whether or not you can even measure an effective porosity from the lab, especially for tight systems like an organic shell. But in general, we'll set this clay porosity somewhere between 10 and 15%. And we'll see that that we now have our total porosity and our effective porosities that have been calculated. And really, that is all there is to calculating a porosity. So that's it, and we'll now be ready to move on and calculate the water saturation. I hope you enjoyed this video, and as always, remember to save your work before moving along.